Good to go? Alrighty, let's get started this morning. Wow, this is massive. Hopefully people can find seats. So I think according to Dave and folks, this is the biggest DerbyCon ever and also sold out as far as I can tell. So thanks for coming. So this presentation is kind of as Dave mentioned, this is my third time keynoting DerbyCon, and I wanted to do something, a little bit contiguous with the previous talks in terms of the same kind of thread. So first off, quick introductions. My name is H.T. Moore. I'm the founder of Metasploit, the chief architect of the Metasploit framework still, and currently I'm head of research for Rapid7. If you want to contact me, this is DerbyCon, so just walk up, say hi, grab a beer, chat, or you can also hit me on Twitter, email, whatever else. So, or if you want some other form of handshaking communication protocol, just stop by in the hallway and say hi. So I'm really honored to speak again this year. Hopefully I haven't screwed up the last 2 years, and it gives me an opportunity to not screw up again this year, hopefully. I really like this conference. It's pretty unique in terms of the type of folks who show up, the just general community vibe. This isn't a conference where you've got this, pantheon of speakers that are all famous people that you can't talk to. They get whisked away after the event. This is a conference where everyone comes here to talk to everyone else. So I'm here not to speak and lecture to you guys, but to actually learn stuff, to get a feel for, what you guys are working on, the challenges you're facing, what other folks are doing in the industry. So it really is a peer-to-peer conference, regardless. And with 125 speakers this year, hopefully that rings more truth than some other conferences. So first off, I'm going to talk a little bit about my first DerbyCon presentation a couple years ago. I was focusing on doing basically digital analysis of audio samples. So dialing lots and lots and lots of phone numbers, tens of thousands of phone numbers, recording the audio of who were having to pick up the phone. And actually, crunching that data to figure out whether it's a phone, whether it's a voice line, whether it's a fax machine, whether it's a voicemail, whether the person was male, whether they're female, whether it's a recording, whether it's a known recording. Lots of really cool stuff with the data. So the idea behind this was you can take something that wasn't really designed to be, mass analyzed digitally, but because of technology, because of how far we've come, because of the resources available, you can now do this stuff really cheaply. And kind of my takeaway from that was this is a, neat way to kind of approach technology in general, looking at things that have been prohibitive at a cost level or from a technology standpoint, and trying to find ways to really do deep security analysis with kind of our current level of resources and software available. So working on Warbox was interesting because I found a lot of challenges I didn't expect, things like legal hurdles, two-party call states, various statutes I wasn't aware of until various lawyers called me and told me, things like that. So, Warbox was fun, but it wasn't really successful for a bunch of reasons. And I kind of look at Warbox as, a cool idea, but really kind of fell flat in its face in terms of execution. And the reason for it is you can't have software that's difficult to configure and then puts the user at legal risk of using it, which is generally challenging. And it's really hard for anybody to see the value of having someone call their phone numbers and all the users. So I felt like it was a cool idea, but it didn't pan out for a bunch of reasons. And, I kind of took some lessons learned. The software's still out there and still maintaining it, but it was something that was a little bit different from, other things I've worked on, and I felt like it was a cool approach to technology, but wasn't the right approach. So last year I talked about doing large-scale internet scanning. This isn't, anything new. Shodan's been doing it for years. Folks have been doing it, all day long in the background for as long as there's been an internet, people have been scanning it. I spent some time drilling into about 18 different protocols, basically scanning every IP on the internet for, different services, different ports, different probes. Generating lots and lots of hate mail, something like 3,300 complaints over the course of a year. Found some really neat stuff though. Things that jumped out that we didn't expect were the fact that the most prevalent UDP service on the internet is UPnP, and it's also the most exploitable. And there's 0 day in all 3 popular stacks for it. So we have issues like that that didn't really come to light until you look at the entire data set as a whole, and you can figure out where the big issues start to bubble up. So it was neat that, you can actually take the IPv4 internet, and it's more of a kiddie pool than this nebulous, unknowable thing anymore. It used to be that scanning the internet was challenging because you don't really know what's out there. It's hard to really, grasp everything that happened to be out there, the connectivity of all the various nations and, states and regions and, devices and technologies and networks. These days, it's very easy to get your hands around it. You can go to Shodan and do a query and find every device running a piece of software. You can go through, a number of different services and find out all kinds of things that are, used to be really difficult to dive into yourself. And the real value of this stuff was being able to drill down into issues that weren't really apparent until you saw the whole picture. So I feel like as a security community, we don't really do a good job right now of looking at the big picture. We typically look at, well, here's what enterprises are doing this week, here's BYOD, here's buzzword of the day, here's all the various things we're doing that we care about as, the new hot button issues. But in terms of basic meat and potatoes, are we getting less vulnerable? Are we getting more secure? Are people getting broken into less? Those things are not true. We're actually getting worse as we go on. I'll go into that a little bit going forward. So I felt that working on the Critical I/O project was a lot of fun. I learned a lot of stuff about it. I got to work with some really cool people in terms of analyzing data and finding vulnerabilities. But again, I feel like it kind of failed. The reason for that is it doesn't really make sense for me to go do a bunch of research and tell you about it, and that's it. That doesn't help anybody. I can find some vulnerabilities, I can patch some bugs, but the amount of good I can do with that is pretty useless. Unfortunately, there's still a lot of legal risks around doing large-scale scanning. And being able to get your own hands on that data was difficult. It was, could I be sued for sharing it? There's all kinds of other things out there that made it difficult to really take that project further at the time. And so because the project was really focused on research, your average IT guys didn't really care. If I'm working on locking down my Exchange server, why do I care that UPnP is the most prevalent protocol out there? It's not relevant to me right now. So looking at all the stuff I was working on around Critical I/O, around some of the Warbox stuff, the general kind of tangents of where I was going, what I realized is that we don't need more research in this area. What we need is more people, more doers, more people looking at it, more analysis, and we need to make it practical for people who are actually doing their job day to day. It just doesn't make any sense to just talk about research when there's so much more out there. And I'll go into some of the examples and case studies going forward. So if you look at mass scanning in general, it's really starting to mature. It's not something we're using Nmap to scan the internet in 3.5 months. You're now using things like Zmap to do it on 45 minutes, or mass scan to do it on 3 minutes with 2 gigabit connections, or 2 10 gigabit connections. The scanning tools have gotten ridiculously easy to use, ridiculously useful and powerful. We're seeing a lot of large-scale scanning efforts that span everything from rogue botnets to academia now. So we're seeing that the space of large-scale scanning of internet, basically mapping and categorizing the internet as a whole, is really starting to pick up as of this year. And there's some scary precedents for the legal side. You've got like Weave, who's currently in jail for what's basically incrementing a URL in his URL bar when it comes down to it. Granted, there's many other reasons why you should probably be in jail, but that wasn't one of them. So it's one of those cases where things like CFA reform, things around some of the prosecution around CFA are actually negative precedents. But at the same time, we've got folks like the University of Michigan doing full internet scans and sharing all their data as of today, actually, which we'll go into in a bit. Which are kind of pushing that back and saying, this is a legitimate tool, this is what people should be doing, this is valuable data, let's not hide it, let's not pretend that we're going to get sued if we share it. So moving on, so I'll talk about the Zmap guys real quick. University of Michigan, two grad students working for Professor J. Alex Halderman put together a project called Zmap. Zmap is basically a packet blaster. You give it a probe, and you tell it to scan the internet, and it does it really quickly. So these guys can basically send a single TCP probe, whether it's a SYN packet, UDP, ICMP, whatever it happens to be, across the whole internet, 45 minutes on regular hardware. So you don't need a crazy machine for this. You can go to singlehop.net, Linode, Amazon, wherever you want to go, and basically set up a box and do this yourself pretty quickly. They put together a pretty ridiculously detailed research paper where they not only went through and scanned SSL for 18 months straight, they also did some tracking of existing vulnerabilities. They took the UPnP vulnerabilities we disclosed back in January, and they actually tested them again 3 or 4 months later to figure out whether there was any differences or not, and actually looked at the difference of vulnerability and exposure. That's great stuff, especially with an academic institution doing it, because they tend to carry a lot of weight with legitimacy and preventing preventing other folks from doing this from getting put in jail, basically. So if you want to dig into it, the development's still on GitHub. The Repsum guys are contributing to it. Hopefully, we'll get more patches from other folks. And one thing that's really cool about this is it can actually do forged socket support. So in other words, when Zmap is sending out 500,000 SYN packets per second out to all these random hosts, and some of these hosts are responding back with a SYN ACK, it can actually use the forged socket kernel module in Linux to pick up that connection in userland and actually start working it with userland tools on the fly without making a new connection entirely. So it's SYN scanning that actually hijacks the half connection that comes back and works. So some really cool stuff's happening in Zmap. So dig into it. Zmap.io is the website for all the fun stuff going on. And if you want to scan port 80 across the entire internet and put it all in one big result file, that's the only command line you need. That's it. So like I said, the mass scanning tools really are getting much further along than they used to be. They're getting much easier to use, and they're much cheaper to run. So if you look at some of the data that was collected by the Zmap guys, they did over 110 different internet-wide SSL scans in the last year alone. They basically built a detailed view of the entire SSL ecosystem, everything from certificates to certificate chains to cipher usage to trying to detect things like man-in-the-middle attacks or reused keys or weak RSA keys, the whole gamut. So I don't want to steal their thunder, but they've really done an awesome job of taking apart SSL, and you'll see more data around that coming out as we go forward. During the Superstorm Sandy storm that hit the East Coast, they actually monitored the SSL space every 2 hours for the 2 days, 3 days around the storm itself, and could actually map the outages that are happening in real time as data centers in New York are being flooded. So it's pretty ridiculous data, and that data set's now online today, and we'll go into a little bit about that earlier. But it's pretty crazy. You can actually map real-world events against, basically network conditions. Over the course of this year or so, they basically pulled up 43 million unique certificates out there. So 43 million unique SSL certs, leaf certificates, intermediates, CAs, etc., and found some pretty cool stuff. So I don't want to steal their thunder, but they did some really awesome work on data collection. If you look at another project that recently was announced, I think last week, Bob Graham at Aratasec released MassScan, which has one missing S somewhere, but that's how they named it, so it's not a typo. So you can scan all of IPv4 for a single port in 3 minutes, apparently. And it's got a little asterisk by that, because you actually need two 10 gigabit Ethernet cards and a PF ring configuration in your kernel to do it. And you actually will blast any ISP on Earth out of the water trying to do this. So technically, you could do this in 3 minutes, but if you actually want to have it return results and not break your ISP and have black helicopter swoop down, you really should look at 45 minutes. So anyways. So, good work for making something go much faster, but it's not practical to actually use in the real world unless you're, sitting on the core of the network or your Arbor network and have a tab everywhere or something like that. So again, that's on GitHub as well, but it gives you an idea of how easy these tools are. Basically, MassScan-P 8000, done. So another quick way to map the entire internet in 3 minutes if you have a, fat enough pipe. So I don't want to forget it, but Nmap has actually made some ridiculous strides in the last year or so as well. Nmap 640 has just a massive number of performance improvements. A lot of folks complain about Nmap, like to use Nmap as a punching bag when they write these new one-off scan tools. But there's a big difference. If you look at something like Zmap or MassScan, their entire goal is to send one thing as fast as they possibly can on the network, and that's it. It's basically a write in a loop, a really tight loop in C that's writing out the same packet to a socket again and again as fast as it can, changing destination headers. Nmap does everything else. Nmap's got Lua built into it. Nmap can take screenshots of websites. So it's not necessarily a fair comparison to say Nmap is slow when one can take pictures of websites and one can send out a packet. So I don't want to definitely don't don't talk bad about Nmap just because it's not sending out 500,000 packets per second, but you can actually get pretty damn close to it. You can get close to 250,000 packets per second out of Nmap alone with proper tuning. So you mess with things like min rate settings, with max rate settings, with RTG timeouts, you can get ridiculously close to some of the Zmap and Zmap and MassScan speeds just using Nmap alone these days. And again, it's definitely a Swiss Army knife of scanning. You can do a lot more, has more flexibility. So don't discount Nmap just because it's the the older kid on the block. One thing that's different about a lot of these tools is they typically don't do more than one attempt to send the same packet. So the Zmap guys, for example, went through and said that if we send a single SYN packet to every IP on the internet, and then we send 2 SYN packets to every IP on the internet, what's the difference? How much data loss are we getting by only sending 1 packet? It was less than 2%. So if you look at the way that Nmap currently does negotiation and SYN scanning, its minimum retry count is 3. So you actually save a whole lot of time, get much more comparable results between Nmap and tools like Zmap, just by setting your retry count back to 1 and setting min rates. So anyways, just a long way of saying don't bag on Nmap just because it's not new and shiny. It actually does a pretty damn good job these days, even though it's not the latest thing. So it's hard to talk about mass scanning without going into more detail on Internet Census 2012. For folks who are aware of this, this is some crazy bastard who broke into 1.2 million embedded devices and then picked out of 420,000 of those, installed a embedded binary botnet, and used that to basically port scan the entire internet twice over the course of 2012. And not a single network intelligence vendor noticed. So if you've got a threat feed and they didn't tell you about this last year, you should ask them why. It's fun. You can watch them squirm. So anyway, someone compromised like 500,000 machines or over 1 million machines total basically for the entire account, and no one really noticed until he published a excellent write-up, animated GIFs, 9 terabytes of data. I mean, there's a ridiculous amount of work that went into this, and unfortunately it's all illegal as hell, so how well you can use it, I'm not sure. But it's actually pretty cool in terms of the amount of work that was done, the amount of data that was shared. So, anyways, as far as I know, the guy's not in jail yet. So hopefully, he won't go to jail because I think it's a cool project and it wasn't malicious. But we'll see what happens, and hopefully there'll be a more detailed write-up on it at some other point. And with any luck, we can get to the same type of data being available in a legal sense. So, if you want to start getting started with internet scanning, first off, why do you care? And we'll get into some of the reasons why later on. But that's usually the first thing people push back on is, why would I want to scan the internet? Why do I care? How is it relevant to what I do? But you also see a lot of concerns around the legalities of scanning. It's a gray area in some states. You've got some ridiculous state laws that don't really define the term access well. They don't define the term outage. They don't define the term damage. So, depending on what lawyer you talk to, there's a lot of, a gray area between what could be deemed illegal, what is actually illegal. As far as I know, port scanning isn't actually a crime anywhere in the U.S. No matter how you look at it, and a judge could argue one way or another, or a prosecutor can argue one way or another, but it's not actually listed as a crime, port scanning by itself. You do get a crap load of abuse complaints, though. Like I said, over the course of running Critical I/O, we got 3,300 abuse complaints. In our latest project, which we'll talk about in a second, we got something close to like 50 or 60 in the first run. And of course, there's computing time and cost to actually run this stuff. But it's not free to run this stuff, but it's pretty cheap these days. So right now, internet scanning is really a niche field. This is an area kind of similar to, exploit development or, reverse engineering 10 years ago. People, got started on it. There's a couple guys really doing a lot of stuff around it today, or around it at the time, but it wasn't something everyone else cared about, did, or really thought of as a tool that's part of their arsenal. The challenges we mentioned earlier, things like legal risk, resource costs, dealing with abuse complaints, time, et cetera, really are, one of the barriers to research. But a lot of businesses also see this stuff as a threat. The reason for that is if you know everything that happens on their network over the course of 2 or 3 years, and then they get breached, and they try to spin a PR story about how the breach happened, you can prove them wrong, they're not going to like that very much. So we're actually, I wish we had the data finished today, but we've been digging into the correlation between SSL certificate revocations and announced data breaches. We're seeing some really interesting things where if you go back in time and you look at where, a particular company, I'm not going to mention names offhand because in case they're here and shoot me, but let's say there's a large company, has their site breached. A couple weeks later, they tell everyone about it, they reset everyone's passwords, they figure it all out, they do instant response. If you actually start going back in time and looking at what their network looked like and when they basically revoke their SSL certificates, you get a pretty good idea of when they know they're breached. And you compare that with the timeline their PR gives you, they don't really match. So there's a case that hopefully we can talk about next week once it gets more data behind it, but basically there's a large retail store that got breached, and they put together a timeline and said what happened, and then going looking at the data, that's not actually what happened by a pretty long stretch. There's like a 2 or 3 month difference between when their admins noticed the breach and when they actually announced the change, or announced the attack. So it was interesting data out there. So one of the reasons why this stuff gets a lot of pushback is businesses don't like it when you call them out on their BS. Neither do governments, neither do anybody else. Like if you have your local hospital gets compromised and they steal your medical records and you can prove that they're negligent based on the conditions of the network at that time, that day, they're also not going to like that very much. So anyways, I see the internet scanning area as being not only a really good tool for research, but for also internal IT usage, and I'll go into some more of those cases in a second, but also a good way to kind of keep our vendors, keep our partners, keep our other peers in the industry honest with how they approach network security and what they're doing about it. We don't have negligence laws so far when it comes to security, with the exception of like HIPAA and high tech to some extent. But as more laws around data breach notification, negligence around network security become a real issue, this stuff will become the hotter topic. So one thing I want to talk about real quick is we go to conferences a lot. I think most folks here have probably gone to more than one conference the last few years. If not, welcome. This is awesome. Conferences are fun. But we look at conferences more as a way to like see peers and network and talk to folks and see a couple shiny topics, then go back to work. I almost look at conferences as being kind of like a holiday. You get out of your bucket for a while, you get out of your day-to-day grind, you get to kind of like see some other stuff that's going on. But unfortunately, just like every other holiday, by the time you get back from your beach vacation, wherever it happens to be, and you talk about starting your own business, doing your own thing, the normal weight of your daily life grinds you back down again. You get back to reality pretty quick and say, well, that was all nice and shiny, but I've got to do this right now because this is what I'm currently doing. I think we should stop that. I think we need to actually look at conferences as a way to actually not just talk about new ideas, but put together plans to change things, both across the industry and across our own interactions with each other. I can't tell you the number of times I've gone to a conference, saw something cool, said, oh, look into it later, and never did anything about it again. I mean, I feel like it was a waste of my time, a waste of the speaker's time. I didn't really get a chance to really leverage what I knew. Thought I was in the idea, but I didn't do anything about it. So, you don't have to do this for my talk, of course, but I would challenge you at DerbyCon this year, take something back with you that you actually put into production, that you actually change how you do your day-to-day work based on something you saw here, someone you talked to, some idea that came across. There's some awesome talks coming through. Hopefully one of these will be something that, relates to your business, relates to you in a way that you can actually make a change in how you operate. Because, we're kind of failing right now in terms of security. We're not getting better in a lot of ways, and the only way to do that is really change what we're doing. So anyways, I just want to throw that out there that, instead of looking at this as a conference where you get some notes and go back home and get back to work again, look at this as a way to reevaluate what you do every day and find ways to improve it. So looking at internet scan data, this stuff is really useful. There's a lot of reasons why you want to have this data that aren't readily apparent to people who aren't involved in this stuff. You can identify, basically quantify widespread vulnerabilities. If someone announces a new vulnerability saying, hey, this particular F5 load balancer has a private key on it, you want to be able to actually query that and see how many devices actually have this exposure, how many of these devices actually have this particular vulnerability on my network and abroad. You can't do that without scanning everything and finding out. If you're trying to do due diligence on a partner, you're trying to figure out whether you want to use this particular third-party hosting company or this marketing organization. How great would it be if you can just go look at their IP ranges first, get a feel for what exposures they have before even engaging with them in the first place, and get a feeling for, if they're using classic ASP for all their websites, you're probably not going to want to do business with them for a bunch of reasons. If you see that it's running PHP MyAdmin or it's got a number of vulnerabilities that are easily apparent through a brief scan, tell them out on all the routers, things like that, it's probably not a company you want to do business with. And by applying that kind of pressure going forward, we can actually make sure that our partners, our business vendors, ourselves are much more secure going forward as well. It's interesting for market share as well. If you're trying to figure out, should I bother patching this software? Is this the right software for me to use? Is this the right software for us to integrate with? You can actually figure out what the market share is by looking at widespread scan data as well. Doing a quick query with something like Redmine or for another ticketing system will give you an idea of what that particular ticketing system share is across the marketplace. You can also use this to locate lots of unmanaged corporate assets. I can't tell you the number of times that I've only found stuff about my own company with Rapid7 stuff because I've gone through a internet-wide scan and found something out there that no one else knew about. Oftentimes you've got developers who take a corporate Amex card, go to Linode, set up a box, hit the reverse DNS port, and walk away. 3 weeks later they pick up a better job at Facebook or a different job at Zynga or wherever they happen to go, and you have no idea this box is hanging out there with your data on it until you actually find it in these widespread scans. So there's a lot of things out there that you can really get a better handle on things like your shadow IT if you have access to these large databases of existing scan results. So if you look at across 2 or 3 years I've been doing large-scale scans with enough data that I can actually start looking at trends, it's really hard to find any measurable improvement across any single line we've looked at. Really basic things like the VxWorks debugger backdoor and embedded devices. This is something that we covered in, I think, 2008, 2009, 2010, somewhere in there. It's still getting worse day to day. There's actually more devices with this vulnerability on the internet every single day than there were the day before, because more devices are being shipped with older firmwares and no one's patching this stuff. So it's hard to say that we're learning more about security and we're getting better. We're learning more about it, but we're still getting worse. We still have this garbage heap of embedded devices and legacy gear kind of heaping up around us, and we're not getting rid of, we're not fixing. Vendors aren't being held accountable to the point with actually resolving the problems of their systems. In the UPnP space, this is a pretty basic set of vulnerabilities. 8 different Stack Overflows and 60 lines of code is ridiculously bad. The vendors, in some cases, put up patches, but users don't apply those patches. ISPs don't push out new devices that can accept them, etc. So the state of things is that some vendors kind of move the bricks around, if you will, but the state of vulnerability didn't really change much. These days the big DDoS topic. Anytime there's a major DDoS, people say, is being done through DNS amplification. DNS amplification is pretty nasty. It's there's something like 48 million plus open DNS resolvers out there you can use to do an amplification attack. But there's actually more than that at SNMP servers that can be used in the same fashion. So we're spending all of our time trying to lock down one vector for this stuff when attackers can easily switch over to another vector just as easily. And it seems like we're kind of just churning on a treadmill right now. We're not going anywhere. And we need to find some way to really drive things forward. So for that, I really think that it's time to make some big changes. It's time for us to be able to, this is a rock I think we can move as a community. If enough folks get involved with, not only doing, large-scale scanning itself, but getting involved in the research side, helping out with analysis, contributing to, vulnerability findings, we need to remove the barriers of entry for folks to get involved, to find vulnerabilities, to report them, to hold vendors accountable. This is not happening well today. There's lots of ways we can do that, and that's by demonstrating the value of this stuff to IT, to security, to the business, driving research based on quantitative exposure. So if we see that one particular service is more popular than everything else, we should probably go look into it. We should go probably find vulnerabilities in that because it affects more people than anything else. Building awareness around what public networks actually look like and where those exposures are. It's not right that your local city council has all of your personal information sitting on an Excel spreadsheet on the website. Like, there's things like that where if you were aware of it, you probably wouldn't like it very much. And it's not a matter of, hey, this person is stupid and they're doing it wrong. It's that they just typically don't know. And there's so many hurdles out there for reporting this stuff, for getting involved, for being able to legally do these types of scans that a lot of folks don't get involved. And because of that, things don't move much. So anyways, I'm hoping we can do some level of collaboration that'll turn things around a little bit and hopefully drive folks to move forward a little bit faster because we're not seeing much progress today. And of course, the more people doing this type of work, the easier it is to fight back on the legal side, to do things like CFAA reform, to make sure that this type of work becomes more legal in the future. And I see this coming from the Metasploit standpoint. When I started Metasploit in 2003, exploits were very much considered, weapons, considered, should they be export controlled? There's a lot of cyber this, cyber that talk, even at the time, where, folks were saying that you'd be liable for publishing an exploit. These days, we publish exploits all day long. We publish more than one exploit module a day in Metasploit, and we haven't been sued yet. But it takes getting enough of a widespread public use, demonstrating the values of the public, demonstrating the public good, for that to become the norm. And what I'm saying is that if we look at the way that we're doing vulnerability research, the way we're doing large-scale scanning, data analysis, et cetera, we need to make that the norm so that it becomes a protected class of research going forward. Anyway, so I apologize for all the rants, but I've actually got like fun stuff to share now, so I'll stop the rants. So today we're announcing Project Sonar, and this is a collaboration between Rapid7, who's doing a lot of the backend analysis and some of the community stuff, and also a few of our partners in the space. Project Sonar is a combination of open source tools, open data sets for everybody, and practical applications using this data to actually secure your business and improve things. So if you want to take a look at it, the miniurl.org Sonar will bring you to kind of the landing page and go to some of the details on it. But it basically boils down to scan all the things. So we really feel like this type of scanning is beneficial for everybody, and there's a lot of really great ways to get value out of what's already up there today, as well as things in the future by collaborating and helping out with kind of this community scanning and analysis project. So we're doing a lot of work with a couple other folks in the field. We've been sending out hard drives to researchers for the last 6 months or so in the background, working with John over at Shodan, working with a bunch of researchers in Taiwan, just all over the map. And we're finding some really neat things. Most recently, we partnered with the University of Michigan folks to work on a new data sharing portal that we'll get into in a second as well. But this is definitely an effort that we want to keep going and put some money behind on our side, and hopefully we can move the bar. So on the scanning side today, we're doing a lot of integration with existing tool sets. So for example, we're already integrating with ZMAP. We built the overhauled the UDP Pro backend for ZMAP, added all of the existing critical IO probes to that. We added some NSE scripts to our site that let you do things like detailed hex banner grabbing with Nmap. We added some SL certificate grabbers that are really fast at doing basically 48 million certs in 8 hours, and some really fast DNS lookup tools. By fast, I'm saying like 4 billion lookups in 8 hours if you want to do it. So we're putting together some of our tools and sharing them all that way, as well as putting together archives of all the data we've already gathered so far. So all that critical IO data I talked about last year at DerbyCon is now public and on the web this second. We're sharing it all in the full form. So if you want to see what of your systems in that, grab it, download it, grep it, that's it. It's basically compressed JSON. It's broken out by month. It's really easy to go through and get a historical view of your network, of anyone else's network, et cetera. So, everyone is showed in to some extent. If you look at the data set that's involved, it's about 2.4 terabytes uncompressed, about 355 gigabytes BZ2'd, about 1.57 billion records, and we're planning on uploading the raw data set soon as well, which is around 3 billion records total. But that covers everything from port 21, 22, 25, 23, VNC, SNMP, everything on the map. So if you want to figure out, what SNMP devices were on a particular network at a particular time, this is the data set, and this covers a 10-month period. And we plan on continuing to upload data like this going forward. The second set of data we're releasing is a recent project to scan every SSL cert on the planet. The ZMAP guys are working on a similar stuff as well, but we're happen to be working in parallel, so we're sharing our data as well as they're sharing their data. The cool thing about this is it's every SSL cert that's on port 443 and IPv4 as of September 10th. And we'll keep doing these, I think, once a week is our current schedule that we have planned going forward. This is available with as raw certificates with all X509 chains, et cetera, as well as an IP to name pair, and around 33 million records, about 50 gigabytes uncompressed, or 16 gigs compressed. One thing we did with this is we actually processed it, so we pulled out every, for every X509 cert out there, we grabbed the common name field in the certificate as well as the subject alt names, and then mapped that to the IP address. So the cool thing about this is if you're using SSL to connect to a website, two things have to be true. The common name has to match the actual DNS name in your browser to get there, and the certificate has to be valid to show up. So by definition, if one of these common names or subject alt name strings actually maps to one of the domains that maps to your business, this is a valid certificate for your business. So it's a long way of saying if you want to find every virtual host your business has in one shot, you can just do a quick grep on this file and grab them all in one shot. It also works for things like identifying all your service providers, identifying cloud service providers. There's some really cool things to do with this data. We're also releasing IPv4 reverse DNS lookups for everything. So this is basically one giant reverse DNS lookup file for 1.13 billion records. We're doing these once a week. This is pretty similar to Rob Fuller's Deep Magic website. So if you've used the search engine for PDR records before, you can use this the same way. You can just use grep to basically pull out records. We plan to do this on a regular basis, I think weekly as well. And you find neat things with that as well. What's interesting about reverse DNS is you can actually accidentally take down the internet pretty easily doing this work. So we had a team that was working trying to optimize this process of doing DNS lookups against 3.7 something billion IPs. And the first thing that happened was we broke Amazon. So The Amazon guys called us up saying, hey, can you spread your jobs across like more availability zones because you're killing our DNS caches in between? Like, okay, so we tried that. Like, no, you're still killing them all. Nope, still killing them all. So we end up having to use every single availability zone they have in every region at the same time to not kill their DNS infrastructure doing these lookups and still doing it within 8 hours. So we got that all working great, and then the next Monday morning we got a phone call saying, hey, you killed DNS for this long list of ISPs. So apparently folks only assign 1 or 2 servers to handle all the authoritative DNS for their reverse DNS lookup. So because of that, if the scans aren't distributed properly, you end up sending like 600,000 packets per second to some poor DNS authoritative server. So a long way of saying, we accidentally DDoS some folks in the process of getting this right, but at this point we've got the scans down to, we upped it from 8 hours to 24 hours, and we've got the per authoritative DNS server load down to around 4,000 or 5,000 packets per second at the most. So long way of actually getting to the result we wanted with the time frame we wanted, but it was kind of funny of all the ways you can break the internet doing DNS lookups. So going forward, we're actually working with the University of Michigan ZMAP team to collaborate on a shared scan data portal. So instead of going to SourceForge or Rapid7's website, which may be slow depending on where we host it, we're putting together a shared server that has a dedicated fiber connection at University of Michigan. So not only are we sharing data, you can actually download it, which is usually a pretty big distinction. A lot of data sets are really tough to get because of the download piece of it. So scans.io, if you pop it open right now, there's actually 4 or 5 data sets currently online, maybe 3 or 4 depending where the University of Michigan guys are. We've got something like, I don't know, a couple terabytes of data already on there already, but this is a good way to get started. And this includes all 18 months of SSL scans from the ZMAP guys, includes all the critical I/O data sets, includes all the reverse DNS stuff we just talked about, all the SSL certificates. Some of the data may not be up yet. I was still uploading one of the data sets right before the talk, but we'll get the rest up there. So the nice thing about this is you don't have to go scan the entire internet to do the cool research that needs to be done. And we'll talk about, one of the, some of the things you can do with this research in a second. Should be good on time. So if you want to find craploads of zero day and sell to ZDI and make $1 million, you can do that right now. You don't really need to be an awesome hacker to do it. All you need to do is download one of these data sets, run a couple grep commands, figure out who the vendors are, write them up, and sell them, and you're done. That's actually as hard as it is right now to find zero day. There's so much data out there, there's so many vulnerabilities, there's so many bad devices, so many buggy products that this isn't a challenge anymore. This is just a bulk effort to classify them at this point. If you look at basically, it's more about grepping than it is about scanning. So the easy way to find vulnerabilities in this stuff, we're looking for any kind of min-max situation where you have, if you look at the most popular version, most popular web server, most popular DNS service, most popular mail server, you start to figure out what the most common versions of those things are. And say, okay, great, it's SendMail, it's Postfix, it's XM, but what's this other wonky web server down here in the middle that's used by a bunch of businesses that I don't know about? So you tend to find all the stuff that gets ignored by researchers or ignored by folks who aren't testing in a particular industry or in a particular vertical or in a particular region because it's not a popular product in that particular area. So just by going through this data, doing some quick sorts on it, you can find some really interesting things and find new targets for research that'll make you $1 million to ZDI or to selling to the NSA or whoever you happen to be selling your bugs to. But basically, for finding vulnerabilities, all you need is a Unix pipeline of grep, sort, awk, publish, and you're basically done. If you want to call BS on that, let me know. I've got a hard drive with me. We can start digging through it right now if you like. But it's just ridiculously how many vulnerable devices are out there, how many haven't been classified, how many haven't been reported, and there's definitely some good incentives to do that these days. Another thing that's good to look at when you have this much data is looking for random things that aren't random. So anytime you have a massive set of 43 million SSL certificates, they should obviously be unique if they're different private keys. What you end up finding out is there's tens of thousands of devices out there that have the same private key across all these systems. So obviously that's a bug, but you can't find that bug to look at all the data at once and say, okay, what's the most egregious example of that? What's the next egregious example of that, et cetera. So there's probably 300 or 400 vendors out there right now that are they're basically using static private keys in their hardware, their appliances, their embedded devices. They're represented in this data set. You can easily go pull up, report, work a cert, sell it. What are you going to do with it? The problem is you actually need eyes on the stuff. You can't figure out what, security camera DVR 1.0 is without, doing a little more research to figure out what vendors behind it, who sells the firmware, what the supply chain is, et cetera. So a lot of this tends to be a lot of Google and grep work in the back end to actually figure out who the vendors are and how to report them. But it's a crap load of zero day. SSL fingerprinting is really good. So the common names themselves in these certificates are things like often have the vendor string as part of it. So if you want to find every super micro IPMI controller on the planet to pack them with one of the 3,000 vulnerabilities that you can use, you can actually just grep for super micro and the common name and the email address for the main admin at super micro is listed in the certificate. Oh, and the certificates are strangely not unique in some cases. You also find a case of enterprise appliances. For example, if you want to find every Fortinet firewall on the planet, they all have the same string in their common names field, so you can grep all those out real quick. So it's easy to basically go through and identify a large swath of appliances, a large swath of embedded devices based on these particular types of fingerprints. This also works for things like Polycom video systems for various SIP voice phones, things like that. So looking at it from a different perspective, if you don't want to go sell all your vulnerabilities to ZDI and make millions of dollars, but you actually want to like improve the security of your own environment, there's lots of good things you can do with this data today. It's really useful to identify assets that you might have already missed. You can scan these massive networks very easily. We're working on a pen test recently that covered about 80,000 nodes, and we only had a couple days to do it, which is one of those cases where the scope of the test wasn't quite clear, so we got involved. So we actually managed to basically do a pretty solid discovery run on it in about 5 minutes. We took ZMAP, we did a couple of port scans for the top 100 ports. It took about, I guess, 15 minutes for 100 ports across a couple of boxes, across 80,000 nodes. Then we used all the UDP probes that are part of the UDP probe set in ZMAP that we added. And basically we're able to do like NetBIOS lookups, IPMI, SNP, all the common list of vulnerabilities and things we wanted to look for exposure in this case. And those were all done in a few minutes as well. So it was a really quick way to quickly identify all the assets on the subnet and fast enough that it really didn't have any impact on the network and it didn't take a couple days to do. Nothing's more disappointing than doing a discovery scan on a network and having it finish just when all the laptops already go offline again. And then you have to start all over again because everything changed. So anyways, hopefully I'm very happy that Leon let me bang on his poor network and dig into the data and pull the stuff out. But anyways, it was a fun process and definitely showed the value of doing these kind of large scale scans in a national pen test environment. So having historical data on what's in your network really helps you with the response. If you take a job at a company and you don't really know much about it and you're trying to figure out what's out there, you can go through and look at the historical data, the external ports, external assets going back 18 months or however long you've got history for from these data sets, and to figure out, okay, hey, we actually had 3 routers here, where did they go? Or at one point we had 5 DNS servers, did they get shut down? So it gives you a better idea of what the company was doing before you started. And if you're trying to do incident response, trying to figure out what was out there, it's really tough to try to figure out what's happening at the time of the incident. Being able to go back and look at it historically says, okay, we had 5 servers online, we only see 4. What happened to the other server? Well, you may find out that the attacker wiped the box and powered it offline. Now you don't see it anymore in your scans. So having that historical data helps you not miss things when you're doing the response side of things. So kind of the way I look at incident response, at least from my own perspective, has been it's this constant cycle of identifying assets, cataloging what you have, how where that data should be, what the priority should be of that data in terms of locking down, figuring out what the threats are to that data, calculating the impact that data gets out, looking for attacks and responding to the attacks, then repeating the cycle. But the key thing is, unless you know what you have, you can't really respond to attacks. If you don't know where your data is, you can't protect it. So being able to do large-scale asset identification really quickly through these external data sets is an important part of that. I mentioned earlier that SSL certificates are really useful for asset discovery because they have basically the vhost name baked into them in terms of the subject alt name. This is incredibly useful. I mean, we were going through just our own company stuff, and we realized there's about 10% of the assets that our IT team didn't know about we could only find using SSL common name lookups in the database. That's because we had folks in one department setting up a service with a third party. They got a certificate, but no one actually logged the fact that the certificate was created by somebody. So there's a lot of reasons why certificates and third-party assets actually can end up in the cloud someplace without you knowing about it. So we actually realized that we had 2 or 3 cloud vendors out there that we weren't monitoring that we should have been monitoring as a result of looking through this SSL database. Reverse DNS also provides a really neat slice of data in terms of the nice thing about reverse DNS is your forward DNS doesn't have to match it. So what often happens is you go set up a new server, a third-party colo or a dedicated server farm or VPS. You'll set the reverse DNS name to have, blah, 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 rap7.com is the name of the server. But, your IT team doesn't know about that. There's no way that they can find out that you created the server with reverse DNS mapping to the company. So I'm going to do that is to look at reverse DNS for all the assets out there and then grep the name back out. So we put some examples of this process onto the Project Sonar webpage. We'll talk about that, if you want to go into more detail, we can. But we've used this to do all sorts of things from finding like rogue partners to VPS providers we didn't realize we had boxes at, or accidentally finding all the assets of a particular intelligence agency. Ends up there is people like to screw with reverse DNS a lot, right? Because it's not, there's no way to verify it. So you'll see like a box pop up saying, it's remote office for some intelligence agency. Like, that's hilarious, like someone's screwing with their DNS. Then you do a forward DNS lookup, like, no, that's the real box. Then you look at that still certain, you're like, yep, that's still the real box. Then you realize that entire group of systems are public when they shouldn't be. So you find some crazy stuff looking at just reverse DNS traffic that's really hard to find any other way. I think I mentioned this, but if you want to classify 100,000 nodes and do that with these tools today, UDP pros for various dangerous services. If you want to find every box with IPMI open to the world that you want to, hack through all the IPMI tools that are out there, it's basically, you can one-shot the internet with ZMAP in 45 minutes to find all of them in one shot. So having access to all these large-scale scanning tools and having access to all this data is a really great way to do quick risk assessments. You can do an assessment without sending a single packet now just by looking at one of the existing payloads or one of the existing data sets that are already out there. So I know we're running short on time, so I want to switch to questions real quick. So here we go. So any questions on the stuff so far? Got a couple questions. Do you have microphones, or we just calling them out? Shoot. Great. Fair enough. Thanks. Any other questions or comments? Yes, sir? The question was, so looking at who is data as opposed to DNS data, and I'm assuming you mean who is for domains, not for IP ranges. Okay. So for IP ranges, you can get a bulk access through Aaron or to Ripe, so you can just go download the data and grep it yourself. It's really straightforward. Aaron requires you to actually snail mail an envelope to them, indicating you're not a spammer. But it's not hard to do. It takes a week or two to get it all done. So you can grep that out. So you're trying to figure out, historical ownership of IP ranges is a great way to do that. If we're looking at doing domain history for like DNS domains like comnet, info.org, those are all managed by the particular registrars. So they will not give you that data, or at least they won't give it to you for less than some umpteen $1 million. And if you try to basically build what ends up being a distributed farm to basically query that in a loop across multiple machines, they get really angry at you and tell you it's against the rules and so on. So it's really tough to build a historical whois database and get away with it these days because Verizon and other folks, VeriSign and other folks who are running these TLDs aren't very happy about sharing it. But you can build it. There are people building it anyways, like domain tools, but it is challenging to get to the domain history records. Thanks, Tony. Any other questions? Yes, sir. So the question was, if we look at it from like Internet Things perspective, what kind of odd stuff pops out that wasn't really expected? Probably the most disturbing stuff came out when we started looking into serial port servers. So we took the Internet Census data, Internet Census 2012, that crazy botnet these guys wrote. The neat thing about that data set is it covered 730 plus ports, whereas most of the scans out there cover a much smaller set, like 20 or 30 at the very most. So because it covers such a wide port range, it included things like port 2100, port 3000, port 3100, and those ports are being used for what's basically a direct mapping port between a serial port converter and another embedded device on the other side of it. So you have these devices made by Digi International, by Lantronix, etc., that are essentially a small telnet server on one side and a serial port on the other, and they basically map the serial port directly to telnet. And there's various protocols and features and multiplex and things you can do around that, but that's basically what they do. So the craziest thing we ran into is a thing called the Vaisala humidity sensor. It's basically used for natural gas and oil pipelines. And you have a natural gas pipeline, and you've got a hole that you drill on the side of this thing. You put this little temperature probe inside of it. You screw it back on, and the other side has a GSM modem on it connected to the internet. And there's no authentication. You basically telnet to it. You get a command shell, and you type commands. So the thing that was, normally for a temperature sensor, that's not a big deal, right? Because it's going to tell me, okay, how, yeah, it may be bad if I don't catch an issue. I don't catch the fact that the temperature's higher, humidity's higher, the flow's higher than I need it to be. However, this particular type of sensor has a fun feature called purge. So what purge will do is, in a lot of cases, when you're monitoring a pipeline, a residue will build up on the tip of the probe inside the pipeline. So you need to purge the residue. It does that by superheating the tip of the probe. So you essentially have remote-controlled detonators for natural gas pipelines scattered all across the U.S., where you tell them, you type purge, and it goes boom. Because it superheats the tip of the probe to burn off the residue, which then ignites the natural gas and causes the pipeline to explode. So I had a fun conversation with the Texas Railroad Commission and all the folks doing right-of-way in Texas and all the SCADA operators out there and getting letters mailed out to all the folks about that stuff. But anyway, so that's probably the worst thing we saw so far. There's a lot of other really just terrible stuff, but that was one of the funny ones. Or terrible, depending who you are. Yes, sir? The question was, do you see folks trying to spoof things like Apache banners and other tries to hide their services? Absolutely. You find all kinds of just random stuff out there. You find like IIS servers that act like Apache. You find all kinds of I mean, they tend to be not the norm though. Like one easy way to find that stuff is if you look at all the headers coming back from the server, and you see that the server header's been changed. We see that the cache control or the e-tag parameters, the e-tag format, like you can usually figure out what the service is even when people try to hide it by looking at either the order of the headers themselves or other fingerprints around it. So there's lots of people who do try to hide the banners of what they're running. Like there's a particular vendor that took OpenSSH and basically patched the binary to be something else, but it's still OpenSSH. And you can easily fingerprint that based on the algorithms, the cipher list that it gives you during negotiation. So you see people doing it, but it's not very effective. Yes, sir? The question is, when we're doing DNS scans, we're looking at just A records or text and RR, et cetera. Currently, we've got 2 projects in the works. One is the reverse DNS project that's basically done. The data's online. That's only looking for pointer records, like INAT or ARPA records for all of IPv4, and that's done. That works great. The next step we're working on is taking a list of all the zone files from all the major TLDs and doing 4 DNS lookups for those for A records, text, et cetera. So the plan is to actually start doing 4 DNS records for all those types you looked at. And I guess the challenge there is making sure we don't overload a particular DNS server in the process, because resources are now plentiful on our side, not necessarily on the side we're querying. Yes, sir? The question was, how many folks are running, are we doing anything with IPv6 to get a feel for, how many people are running IPv6? Not too much so far. This is part of it's tied. So the problem with V6, of course, you can't just like scan from one to billions. It just doesn't work. There are lots of other ways to find assets. So we're looking at taking our 4 DNS research, where we're looking at all the basically we have a list of every com, net, org, info, US, etc. that's registered every day. We're doing a 4 DNS lookup on that to figure out whether it's got a quad A record for any of the common subdomains we're looking for. And once we have a list of those quad A records, we're going to start scanning those and getting information on those assets as well. So that's currently the plan, to get IPv6 scan data into the public eye. We're not there yet. Yes, sir? The question was, there's lots of data. There's lots of data out there, but what's analysis look like? I've gone through a ton of stuff from like Mongo to Elastic to a billion tools, and what I end up coming down to usually is just basically a Mosaic core box with a Unix pipeline. I find like using bzip2 and grep and a couple of Ruby scripts is usually more than enough to do any kind of analysis I want to do in any of these data sets. And that's actually one of the challenges with a lot of the data out there, is that things aren't broken down to small enough chunks you can do anything with it. So one thing we tried to do with the Project Sonar data sets is cut it down into bite-sized enough pieces that you don't need a supercomputer to analyze it. So for example, if you want to look at the mapping of every SSL certificate, common name, and subject alt name to IP address, that's a single 270 megabyte file that we cut out separate. That's just that piece of data that you can then basically run it through grep and anything else in the command line. So right now the analysis tools are, there's lots of neat ways you can throw crazy, big data analysis tools at it, but we haven't really found many uses for that so far. If you look at most of the big data tools out there, they really exceed at doing, one thing, which is you load a bunch of data into it, and they give you the kind of the min-max, the top, top 5 of this, top 10 of that categories. You can get the data out pretty easily. As far as like doing more complicated queries, they tend to be more effort than they're probably worth in some cases. And what we found is that, usually a Unix command line or Linux box is more than powerful enough to do most analysis we need to do so far. At the end of the day, the guys you're giving your data to typically run Excel, so there's only so much you can do with them anyways. So, any other questions? Did I miss anyone? Yes, sir, back there. The question is, have we looked at using BGP tables and ASNs to basically map out ownership to companies? We haven't done it yet. It's actually progress that's in the background right now. We're basically mapping, we're using Aaron's ASN identifiers for network blocks to figure out who owns what, but it's still kind of a separate database. At some point, we're going to link the whole thing together and make that, dumpable in one format. But currently, that's a separate project we haven't brought up yet. But it's definitely useful for the ownership side. It's not necessarily useful for the analysis that we're doing these days. Any other questions? I think we've got time for 1 or 2 more. Oh, yes. The comment in the question was, the ZMAP paper mentioned that they triggered all sorts of IPS and IDS alerts as well as blocks. And the question was, does the stuff that we do on the Project Sonar side how does it deal with that? The good news is that we have a giant IP block space. So the ZMAP guys use, I think, like at least 2/24s for their scans. We've got a couple /29s we've used so far. And the nice thing about doing a single one-off scan from an IP they haven't seen before is usually you may get blocked later on, but you won't get blocked for the first time. So you can actually see what your block looks like based on your first scan versus your second scan, how many blocks are in place. And there are cases where you'll hit a darknet and the darknet will blacklist your entire source range before you can get that far into it. I think most of our scans were being done with entire /29 as a source. So I think it's like 15 IPs or something like that is what we're using as our source scans. So far it hasn't been a problem. We did find a couple of really bizarre cases where folks had like a tipping point IPS, but they had it flipped around the wrong way. So they had this large state agency network, and they had an IPS set up in front of it, but the IPS was thinking the internet was inside and the agency was outside, as opposed to the other way around. So what was happening is, anytime you tried to browse any asset inside this agency's network, it would pop up an error saying, no, that site's malicious, we can't let you go to it. So it's bizarre. So they accidentally are protecting the internet from themselves, I guess. But it was, you find some just bizarre stuff out there. There's I'm trying to identify what type of device it is, but if you send like basically arbitrary UDP packets out to every IP in the internet on a bunch of random ports, you start getting these really bogus oddball replies that come back in that are completely fake, like HTTP errors over UDP from some kind of intermediate proxy device that forged the result of the target you're scanning. So you just found some pretty bizarre responses out there, but so far IPS-IDS hasn't really been a problem for data collection. I think we have time for one more here, and then we should be good. Yes, sir? For our scans, hopefully not. The one incident I know of is when I did the critical IO scanning back in the beginning of 2012. Something that wasn't clear to me at the time was when you do a STP scan for basically querying every device on the internet for system description field, which is pretty innocuous using community string public. You wouldn't think bad things would happen. Ends up what happens is some of these large data centers have a crap load of PDUs all lined up, and the PDUs are designed to send traps when they receive any error. And one of the errors they receive is invalid community string. So if you've got a PDU at a big data center and you set community string to be not public, and it sets up to basically send a trap message when it receives any error, then basically you flood every single person's pager that works at a particular colo center every time you do a scan. And they don't like that very much on holiday weekends. But that's the only real impact we've heard about so far. I think that's it for time. Definitely drop by and say hi to me in the conference. Yes, sir? Oh, sure. Let me see if I can do that real quick. That's a good question. Probably not. I don't know if it's readable. So there's actually something related to the CTF for the cake on the slide, but it's hard to see. It's in that bottom row there, so I'm not sure if anyone can read the text. You might have to get pretty close to the screen to see it. Rob, is it readable at all, or is it totally screwed? Sorry. Oh, crap. Oh, you're right. Let's see. There you go. Is that readable now? So this is somewhat related to the cake contest. Is all I'm allowed to say, I think. Well, thank you guys for your time. Appreciate it. Have a good time at DerbyCon, and hit me up if you need anything.